Hello everyone, welcome to our 15th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheeraj Chaudhary and today we will explore Lambda functions, which are small anonymous functions defined with more concise syntax compared to our regular function syntax that we have seen in our previous videos. Lambda functions are particularly useful in data pre-processing tasks of artificial intelligence and machine learning, where you often need to transform or filter data using simple one-liner operations. Now, Lambda functions are anonymous functions created with a Lambda keyword. So whenever you're going to define a Lambda function, it will start with the Lambda keyword. Unlike regular expressions, unlike regular functions that we saw in our previous video where we define our function with the keyword def, a Lambda function don't have a name unless assigned to a variable. So the syntax is very simple. The Lambda keyword followed by a parameter and a colon, then a single expression. That is how the code looks. So I will show you how you define your Lambda function. So you define your Lambda functions like this, where what you do is it starts with Lambda, okay, that the keyword Lambda followed by the parameter, then a colon, and then a single expression. So over here I have provided a single expression. This is how you define your Lambda functions compared to the way you define your regular functions that we saw in our last video. And Lambda functions are limited to single expressions. They can't contain multiple statements or complex logic. When you have a simple logic that needs to be executed, then and only then use Lambda. When you have complex logic, go ahead with our regular functions, that is with def keyword. So Lambda functions are typically defined when they are used, making your code more concise when you need simple functions. So let's understand this with our example. So what our first example is doing is, so first I go ahead and define our function square with the parameter x, which is going to return us the exponential of 2 for the x value. And this is a regular function as we saw in our previous video. It takes x, squares it, and returns the result. Simple and readable, right? And when we call square 5 over here, as you see, square, and we pass the parameter as 5, it is going to give us the result, which is going to be the power of 2, that is 25. 5 5s are 25. Now, the second example, then we create a variable square underscore lambda is equal to lambda x and x to the power of 2. So over here we are defining the same logic using lambda function where lambda x colon, that is lambda x colon. This means that the function takes one parameter called x at a time. That means the parameter that we have defined over here, the same way we are defining that we are going to accept only one parameter at a time. So if I write here x, y, z, a, b, c, so it is going to take 6 parameters. If I write x, y, z, then it is going to take 3 parameters. So whatever parameters we have to define while calling the function, we have to provide it over here in this format. Okay, then we move towards the other part, that is the expression. So this is the expression that it is going to run, and as soon as it runs it, it is going to return that to the variable that we have created. So it is variable it has created, that is square lambda. So we can use it like a normal function also, where we are getting our value in return. So if I go ahead and run this, what it is going to do is it is so when I say square lambda 5, so 5 is going to come in as our argument that we have declared over here, and we are passing as a parameter we have declared over here, and we are passing that as an argument, and based on that argument we are doing the exponential of we are doing square of 2, and when I go ahead and run this, it is going to say 25, which is the square of 5. Sorry, it is not exponential, my bad upon that. Now let's take another example. So previously you saw that I called the function and then I passed the argument over here, but you can also do it in other way, where if you directly want to print value, you can define the lambda function in this way, where we have defined the lambda over here, but the argument that we are passing, so instead of calling it with the name, you can directly pass the argument like this also, and it is also going to give you the same result. So that is the beauty of using lambda functions. Now, so if we understand from the diagrammatic format, so it is small anonymous functions that we saw, which is not having any name. It starts with lambda. Then we define using it lambda keyword, as we saw, the basic syntax we saw. Then we saw the expressions at the end, and the expressions that we give, it is being evaluated and it is going to be returned to our variable. And the expressions that it is going to run, it is limited to single expressions only for lambda functions, and it is created where they are used in lines. So usually it is created when we want a inline operation to be performed, which is known as lambda expressions. Now, before going ahead and exploring the inbuilt methods of lambda and how we can use it in complex operations, let's first understand when we should use regular functions and when we should use lambda functions. So lambda functions are ideal for simple operations that can be expressed in a single line, as we saw, as they are anonymous and defined in line with an implicit return of the expression value. And regular functions, on the other hand, are better for complex logic requiring multiple lines of code. They have names, can include docstring, type hints, and allow for more readable implementation of complex operations. So you can choose between both of them based on the complexity, reusability, and the readability of your code. So let's understand this with an example. So one example is going to be the regular one, and the other one is going to be with the lambda functions. So over here, when I am defining the lambda functions, what all I am covering over here, this is a bit complex compared to our previous example, because over here, see, I am passing four different arguments over here, right? Along with that, I am passing a doc string where I am providing documentation for my function. That is one of the feature of functions. Then I am providing two operations over here. After providing two operations of over here for the variable creation, after that, again, I am performing an operation and then returning the value when this function has been called. Okay. So this is a bit of complex operation where what exactly we are doing, we are calculating the distance, and it has multiple steps where first you compute difference between x and y values, that is x2 minus xy and y2 minus y1. Then you calculate using Euclidean distance formula, that is x2 minus x1 square and y2 minus y1 square. And this logic is a multiple line logic that can be reusable. That's why we have written that as part of a function over here. So if I go ahead and run this, and this is how you get an output. This gives you an example of a complex functions that we define. Okay, so right now it is not giving any output. The reason for that is I have not used saved it by using a print statement. Now, when we go ahead and use lambda functions. So over here, what I am doing is, in this, the lambda function, we are using inside map. It is used to compute the distance from the origin, that is 0, 0 for each point in the list. Suppose we have a graph and we start with the origin, that is 0, 0. Then we go after each point one by one. So it takes a tuple point. So these are the ones which are defined as part of this list. These are the tuples. So we have three tuples that we have taken. So what it is going to do is, it is going to take a tuple point and it is going to square its x and y, and then it will add them and then take the square root. And you can see the logic is very short, where we are performing a single line operation. So since the logic is short, what we can do is we can use this kinds of operation only once, and which we are not going to use it again and again, because over here we are trying to find the compute distances from the origin, which is not a every time thing, because it will be different for everyone and not much reusable. So for this kind of task, we can use lambda functions, where you can write your lambda functions like this. So for now, don't worry, I am going to dive into this format of using map inbuilt function, which will come later on in our next slides. So so to conclude, what we would say that we would use regular functions for complex and reusable logic. So over here you can see that this can be reused, and the second one is the lambda function for short one-off operations, especially by using map, filtering, or sorting, that we will see in our upcoming slides. Now let's go ahead and talk about how we can use lambda with built-in functions. So lambda functions are particularly useful when combined with built-in Python functions that take other functions as an arguments. And this include map for transforming sequences, filter for selecting items based on a condition, and the sorted for custom sorting, and last but not the least, reduce from the module that is named function tools for aggregating values. So in this context, lambda functions allows you to define the operation inline without creating a named function separately. So this leads to more concise and functional style code, and without lambdas, you would need to define separate function for each of this operation, making your code more verbose. So in data processing, pre-processing, and artificial intelligence and machine learning, the combinations are frequently used for data transformation, feature engineering, and pre-processing steps that we perform before our model building. Now, let's understand each one of them by deep diving into it. The map function applies a given function to each item in an iterable, returning a map object that can be converted to a list or a iterator. And when combined with lambda functions, map becomes a powerful tool for concise data transformation. Map is especially efficient because it applies the function lazily, only generating values when needed, which can be important for memory efficiency when working with large datasets. The combination of map and lambda is staple in data processing pipelines for converting, scaling, or otherwise transforming features in your data. Let's understand map with few examples. So I will jump to our coding editor, and over here are the few examples, and we'll talk out each one of them. So map applies a function to each item in the numbered list. What we mean by that? So map is going to iterate through each item from the list that has been provided over here. That's what map does. It is going to iterate over each numbers. Once it iterate over each number, then comes the lambda, where we have defined lambda x is going to perform an operation of x square of 2. So what it is going to do is, every time it is going to iterate inside this list, it is going to pick one value. It is going to pass that value as x to lambda, and then it is going to perform a square of that specific number. So if I go ahead and run this code, you will see it is going to give a square of each one of the element inside the list. So how it worked? So as soon as we initiated it, this map helped us to iterate through these numbers that we have defined over here. Okay, so what it is doing is, first it will go to 1, then with the help of lambda function, it is going to do the square of 1, which is 1. Then square of 2 is going to be 4, square of 3 is going to be 9, square of 4 is going to be 16, square of 5 is going to be 25. That is how you can club the map function with the lambda function, and you don't need to write another function explicitly to perform this operation. Now let's talk about another example where we are transforming the strings by again using the map functions along with lambda. So over here, what's happening? Each string in the name list is passed to s dot capitalize. So map is going to go to the list. Once it goes to the list, then it is going to pick each string from the list that we have. So first it is going to pick the name Alice, and it is going to bring it to lambda. Then what lambda is going to do is, this lambda is going to pass it as s to this operation that we are performing, that is s dot capitalize. What s dot capitalize is going to do is, it is going to make this lowercase word into uppercase. So if I go ahead and run this, it will run for 3 times, and it will convert all the 3 values. So capitalize is going to make the first character of your word capital. That's why over here you can see Alice is all in lowercase. Now it has gone ahead and made a capital at the start. Same for Bob and same for Charlie. Now let's go ahead and see another example. So here map takes 2 lists, list 1 and list 2. Okay, that's what you can see. Map is taking 2 lists, numbers 1 and numbers 2. Now the lambda adds corresponding items. What it is going to do is, the way we are going to iterate over each list, so every time it iterates, so first it will iterate and pick 1 from numbers 1 and 4 from numbers 2. So what we are doing, we are capturing both of them. So we are taking 1 plus 4, then 2 plus 5, then 3 plus 6. So if I go ahead and run this, you can see 1 plus 4 is 5, 5 plus 2 is 7, and 6 plus 3 is 9. This is how you can use it with multiple iterables as part of map and lambda combo. Now, the last example. So in this example, we are trying to go ahead and perform normalizing, create some normalizing values. How we are doing that? So first we get the maximum value in the list. So for doing that, what we do is we first of all we are passing the values. Okay, then it is going to go ahead and find the maximum value. Once it finds the maximum value, then we are going to divide every item by the maximum using map. So how we are doing that? So uh, this is our list from 10 to 50. First, when we said max vals, it is going to return 50 over here. So what I will do, I will just go ahead and print. So this is going to print the value of max value over here. Okay, so first when we say max values, so it is going to find 50 and it is going to print that for us because that has been saved into max value. Now then we go ahead and initiate our combination of map and lambda, where what we are saying is we are going to go through each of the elements from the list 10, 20, 30, 40, 50, and we are going to divide each value with the maximum. So 10 divided by 50, 20 by 50, 30 by 50, 40 by 50, and 50 by 50. So if I go ahead and run this, you can see this value is printed once, then an iteration is been performed, and each and every value is been picked and is been divided by the maximum value. So 10 divided by 50 is going to be 10.2, 0.4, 0.6, 0.8, and 1.0, because 50 divided by 50 is going to 1.0. So whenever you perform a divide, it is going to return you a float. We have already covered this in our previous videos. So this is how you can use map along with lambda functions. Now let's deep dive into lambda with filter. That is again another inbuilt function. So the filter function selects items from an iterable where function returns true. So the same way map was selecting the items from the iterable that we were providing, it is going to do that. But in what it is going to do is it is going to return the boolean values, that is true or false. And when you're going to combine lambda functions with filter, it provides a concise way to extract elements that meet specific criteria. The function passed to filter must return a boolean value or something that evaluates to true or false in a boolean context. In machine learning workflows, filtering is essential for data cleaning. You might filter out outliers, remove incomplete records, or select specific subsets of your data for analysis. Like map, filter is also uh, uh, going ahead and treat the data lazily and only generates values when needed. It is not going to run every time, only when it is required to run, making it memory efficient for large data sets. While list comprehension can often replace filter and lambda combinations using filter with the lambda. Uh, let's understand this by going to our examples. So over here we will see few examples by combining our lambda functions with the filter. So in the first example, what we are doing, we are filtering the even numbers. So to do this, in the first example, first we have a list of numbers which ranges from 1 to 10, as you can see. Then we are going ahead and using a filter that has been mentioned over here. What this filter is going to do is it is going to iterate to over the list that we have provided, and while it is going to iterate via the list, we are going ahead and we are providing our expression where we are saying check if the number is even or odd. So if I go ahead and run this, so the numbers which are even and odd, based on that it is returning that as part of the list, and we are getting the number of list of numbers which are even, not odd. Now next example, so over here we are filtering strings by length. So this is the string words which is having 1, 2, 3, 4, 5, 6 elements over here which are strings which are passed as part of this list. So every element is a string that you can see over here. So what we are doing is we are using filter which is going to iterate through each of the string of this list. Once it is going to iterate, what it is going to do is every time it picks a word, a string from this list as an element, it is going to check if the length of that word is greater than 5. If it is greater than 5, if it is true greater than 5, then and only then that value is going to be returned and added as part of the list that is long words. So if I go ahead and run this, so if you see apple 1 2 3 4 5, it is not greater than 5, so it is going to be skipped. Same for other ones. So you can see over here date is also skipped, fig is also skipped because these are not greater than 5. So this is how you can combine filter with lambda to perform filtering of strings by the length. Now the last example for our filtering function. So what we have over here is we have a list of people and each of them are represented in a dictionary, that is a key value pair. So in the first one, for Alice we have age of Alice as 25 and she lives in New York. For Bob, age is 17, he lives in Boston. For Charlie, his age is 32, he lives in New York. For David, his age is 15 and he lives in Chicago. Now we are going ahead and running our function where we say filter people. So it is going to iterate over each of the dictionary inside the list that we have. Okay, so what it is going to do is, so first it is going to filter the adults. So when we are going to filter the adults, so for that what condition we have given is that the person's age should be greater than or equal to 18. So it is going to go through each one of them and it is going to see which record is having the age greater than equal to 18. Once we get that value, it is going to return the list accordingly to us. Then in the next one, what we are filtering the people who stays in New York. For doing that, what we are doing is again we are iterating through each of them one by one, and after iterating we are going to only return those which resides in New York. So if I go ahead and run this, it is going to create both of them. Let me go ahead and print. So this is how you can filter the adults based on the age. And you can also filter the people based on the city they are residing in. So if I go ahead and run this, so you can see now the filtering has happened. So as part of the filtering, for Bob and David, the age is not greater than or equal to 18. That's why they have removed as part of our first return, that is adults. Okay, return value. Then if you see the second one, Alice and Charlie lives in New York. That is the reason we have Alice and Charlie over here. So that is how you can use filtering for filtering the dictionaries by using the combination of filter and lambda. Now let's see what's next. So next we are going to talk about the other function, that is sorted. So the sorted function returns a new sorted list from an iterable. So it's a key parameter which accepts a function that extracts a comparison value from each item, allowing for custom sorting logic. Lambda functions are ideal for creating these key functions since they are typically simple transformations. In data analysis and machine learning, custom sorting is frequently needed for organizing results. The combination of sorted and lambda gives you the flexibility to sort data by any criteria you need without defining separate function for each operations. So this is particularly valuable when you're working with complex data structures like dictionary or custom objects that represent your dataset entries or model results. So let's go ahead and check how we can use the sorted function. So guys, let's understand the sorted function with the help of two examples. So our first example is where we are going to sort strings by length. What do I mean? That means we are going to sort these strings which are part of this list by the length of the characters of the word. So over here you will see this word is having a length of 5, that is it has 5 characters. this is having length of 6 because it has 6 characters. So based on the number, so we are going to sort this from ascending to descending order. So if what our code is going to do is, first we are using the function sorted. What sorted is going to do is, sorted is going to use this list, and for this list it is going to perform this operation, that is key, in which what we are doing, lambda is going to iterate through each of the elements, and once it iterates, it's going ahead and providing the length back to the sorted one, length back to the sorted function. And what sorted function is going to do is, it is going to create a list out of it, and it is going to sort the list of the names of the words over here into ascending to descending order. So if I go ahead and run this, what you will see that it has sorted from ascending to descending, because fig is having 3 letters, date is having 4 letters, apple is having 5 letters, banana is having 6 letters, and cherry is having 7 letters. So this is how you can perform your operation by giving a lambda function inside the key, and the whatever values which are going to come, it is going to be automatically sorted with the help of sorted function, and you can use those values as part of the return list that has been provided to you. Now let's understand another example. This one is a bit complex, so have a look properly. So what we are doing over here is, so first we have a list. So this list over here, you can see it is having the list of students. Those are 4 students, Alice, Bob, Charlie, and David, for whom we have their grades and ages. Okay. Now what we are going to do is, we are going to sort by the grade, that is descending. So whoever is going to have the highest grade is going to be at the top. Then for example, suppose if we have a person A and person B, person A is also having the highest grade and person B is also having the highest grade. So in that scenario, to whom I am going to give the priority when I am going to sort it based on based on the descending format that we are following. So for that, what we are going to do is, if both A and B are having same grades, then we are going to see who is having an age who is smaller in size. So for example, if A is 15 years of age and B is 18 years of age, so we are going to give priority to the age 15. So we are using a combination of the highest grade as well along with the age, whichever is lower. So if I go ahead and talk about the code, so we are using the sorted function over here, where we are passing the student, the list of student over here, which is having multiple dictionaries inside it, with each Unix codes and age for different person. Then we go ahead and run our lambda function. So what our lambda function is going to do is, our lambda function is going to go ahead and sort the list based on the grades. So over here I have given negative. So when I give a minus, then it is going to come from descending to ascending. If I am not going to give that minus, it is going to come from ascending to descending. So this minus indicates that it is coming from descending to ascending. So what I'm saying is, go ahead and sort it in a format where the highest number of grade is going to be top in the list. So once it sorts, and if there is any ties, what it is going to do is, it is going to do an AND operation, where in case of ties, it is going to check the age. So the age which is lower, it is going to give them priority, and it is going to give back the list in a sorted format. So if I go ahead and run this now, and you can see, so right now 92 grade is for Bob as well as with David, right? Now, as I said, the one who is having the less age will be giving more precedence compared to the one who is having higher age. So that's why it has been sorted in this format, where David comes first because his age is 15, even though they both have the same score. Then comes Bob. So that is how you can use the sorted function along with your lambda. Okay, now let's see what's next. So now we are going to talk about lambda in list comprehensions. So in Python, list comprehensions often provide an alternative for using the functions that we saw, that is map and filter with lambda functions. So list comprehensions offer a more concise and something more readable syntax for creating list based on existing sequences. The mapping aspect of list comprehension is expressed in the output expression, while the filtering aspect is expressed in an optional if clause. So if you are working in a functional style with other operators like reduce, using lambda with map and filter might be more consistent. If you prefer a more Pythonic approach, list comprehensions are generally favored compared to this combination that we were using over here of sorted and lambda function. So both the approaches achieve the same result. As I'm going to show you, I'm going to show you the examples, which is going to be with lambda as well as with list comprehension. Then you can decide that which one you want to go for, and both are going to give you the same output. So let's go ahead and talk about our first example. So in our first example, so first I'm going to go ahead and initialize our list, which is going to be from 1 to 5. Then first we are using map function. Okay, so in this what you will see, this line uses map and the lambda function to go through each number as part of numbers list, that is 1 2 3 4 5. So for each number, x is going to calculate its square, and it is going to build a new list of these squared values, and it is going to be returned as part of this entire code that we have written over here. So sorry, my bad, I forgot to add the print statement over here to show you what is the output. Let me add that for all of them. Okay, now if I go ahead and print this, it is going to give us the square of each of the element, that is each of the numbers inside this list. Then the same thing that you can perform without using map and lambda, you can directly use list comprehension. So by using list comprehension, what you want to do is, so over here, first x square 2. So this is the expression that will be included in the new list. Okay, so it is going to square each number. Then for x, so for x in numbers, it is going to iterate through each elements from the number, and it is going to return that to x, and this is going to perform a square of each of the element, and it is going to return the entire squared numbers as part of one list to squares comp. And when we go ahead and run this code, it is also going to provide the same output. So either way, you can do by using lambda, or you can do by using list comprehensions. So depends on your coding style. So because we were thinking that lambda is going to reduce our code, but that list comprehension also does. But now you have to understand that when you have to use a list comprehension and when you have to use lambda, because both of them has their benefits. Now let's talk about another function, that is filter with lambda. So what over here we are doing is, we are doing inbuilt function filter. It is going to filter the numbers, that is the even numbers, and it is going to provide us the list of the even numbers over here, where it is going to iterate through each element of the number, and the number which are even, that and only that is going to be returned as part of the list. And then you can see 2 and 4. The same way over here, you have to write everything. So you have to define the variable, then you have to write the function, then you have to give the condition, and based on that it will give you the same output over here. So over here the part of writing the for loop and everything has been reduced a bit compared to the lambda function, as you can see over there. But this is how you write the filter with lambda, and this is how you write the list comprehension for the equivalent code that we have seen above. Last but not the least, this time we are going to combine map and filter, two different functions together. And when you combine both of them together, what's happening over here is, so it is going to first run the filter, then it is going to run the map. Okay, so if I go ahead and copy this, and sorry, so what was done over here, so it went ahead and first it fetched the even number from the list. Once the even number was fetched from the list, for each even number which was fetched from the list, it has passed each even number to this second lambda function, that is map. And what map is and what is happening over here inside this lambda function, it is making the square of those numbers, those even numbers which are been returned as part of this one. So that's why this we have two even numbers, as you see, 2 and 4. So it has returned a square of 2 and 4, which is 4 and 16 over here. Now the equivalent list comprehension would be like this. So in this, what we are doing is, we are going ahead and we are performing the square over here. So first we are performing the for operation, for loop over here, where it is going to fetch each value from the numbers, that is from 1 to 5, and then we are performing the other operation over here. So in this, what's going to happen? First, it is going to this for loop will get initiated, then it is going to filter out the even number values, and it is going to pass it over here, and this is going to be the final return value, which is going to be returned as part of the list, and you will have the equivalent output over here. So the way over here we got that value by using two different functions of lambda, but over here list comprehension was short. So as per my understanding, I think for the third example, I would prefer going with list comprehensions compared to the other one. It is based on your perspective, how you want to go ahead. Now, last but not the least, let's talk about lambda functions, because it is very closely tied to the functional programming, where functions are treated as first class object that can be passed around and composed. So functional programming emphasizes pure functions without side effects, immutable data, and function composition. Python supports many functional programming concepts, and the func tools module that we saw provides additional tools like reduce, which aggregates values in a sequence using a function. While Python isn't a purely functional language, these functional programming techniques can lead to more declarative, concise code for certain problems. In machine learning, functional approaches are often useful for data transformation pipelines, where you want to apply a series of operations to your dataset while keeping the original data unchanged. So let's understand this with two examples. So let's go ahead and understand the functional programming over here with two examples. So our first example, we demonstrate a functional approach. In our first example, we are demonstrating a functional approach for calculating the sum of squares using map with a lambda. So the map with lambda that you see on the right hand side, which is the last number, what it is doing is it is going to actually perform the square of each of the number by iterating through the list of numbers. Once it is going to perform a square, it is going to give that to reduce lambda combo. What reduce lambda combo is going to do is, now the list of squared number which are been provided by map and lambda combo is been added together, and you are going to get an output of 55. How we got 55? So the square of 1 into 1 is 1, 2 into 2 is 4, this become 9, this becomes 16, and this becomes 25. If you add all of them, it is going to go ahead and give you 55. Now let's see another example. So in our second example, we create a compose function that combines two small functions, that is one that doubles a number and another that squares it together. So which are the two small functions? These are the two small functions. So how these functions work? So double the number, that means if I say 3, so it is going to double the number. 3 into 2 is going to be 6, number has been doubled. Now the double number that we got, now once we got that double number, it is going to square that number. So it is going to be 6 square, that is going to be 6 6 are 36. So that is what I was talking about. Again, we create a compose function over here that combines two small functions, one that doubles, that is 3 into 2 example, which is going to be 6, and the another one is going to square it, which is going to be 36. So the idea is to first double, as we saw, then we are going to perform the square of it. So when we call double then square over here, and we are actually passing the value, okay, so this 3 is going to go as part of parameter for square and double. We are going to get the output out of it, and that output we are passing to the compose as an argument, and based on that we are going to get the results. So over here what we did is, so when we called the double than square 3, it returns both step in a order and gives us 36. Okay, so this shows how we can build more complex logic by joining simple functions together. That is a common idea in functional programming that we see. So let's see what's next we have to cover. So now let's talk about some limitations of lambda functions. So while lambda functions are powerful, they have limitations that we should be aware of. The most significant limitation is that they can only contain a single expression, not statements like if else blocks or try except blocks. Lambda functions also can't include docstring or type hints, provided a limited debugging information in tracebacks, and can become difficult to read if the expression is too complex. So because of these limitations, Lambda functions are not ideal for complex logic requiring multiple steps, functions that need documentation, functions used in multiple places, or functions with many arguments. So in these cases, regular functions that we saw defined with the def keyword are more appropriate with all of this requirement where we have to provide a documentation and everything. So over here, we have to remember that the goal is to write clear and maintainable code for which we are trying to use Lambda functions where they can enhance the readability, but we don't have to force the complex logic and bring them into the Lambda function. We have to avoid those complex logic for the Lambda functions, keep it simple, and for complex logic, we have to use our regular functions. So now it's time to see the official documentation for the same. So if I go ahead, so this is the official documentation where it it provides a good coverage of Lambda functions and related concepts. The section on the Lambda expression in the tutorial explains their syntax and basic use case. This is the syntax over here and the basic use cases. So you can go through it. You will get a lot of knowledge by referring. This is up to date official documentation. So thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below and I would be happy to answer them. Remember, programming skills improve with practice. So try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our YouTube channel, and sign up for our Tech Inside Neuron newsletter. All the links are available on the screen as well as it's available in the comments below. So see you in the next video. Take care and bye for now.